Okay, Assalamualaikum, a very good day to all. So right now we are still in chapter 9, mechanics. So now I'm going to explain to you the applications of the vector. So let's proceed now. Okay, so as you can see that before this we discussed about vector, how to calculate a vector, how to find the resolutions or we can actually how to find the resulting reactions of the forces. So now we are going to focus on calculate the moment of forces and a couple, where we need to understand what does it mean by moment, what does it mean by couple, and then we are going to draw a free body diagram, okay, or another name we call as a force body diagram. And the last one is we are going to calculate and solve the questions that involve equilibrium. Okay, so let's proceed with what is the moment. Okay, so what does it mean by moment? Okay, moment, or another name we call as a torque. Okay, moment or torque, and moment represented by capital M, is a tendency of a force to produce a change in rotational motion about an axis or a point. So means that you have a force, and then you have an axis or a point. What happen is going to move in a circular motions. So here, okay, so example, if I draw a beam, okay, and then I put a hinge over here, or in SPM, if I'm not mistaken, you call it as a fulcrum. Okay, here we didn't use fulcrum, we mostly use for hinge. Okay, and then what happen is when you apply force perpendicular to what this one we call as a level arm. Okay, so when you apply force perpendicular to the level arm, what happen is going to move in a circular motions or move in rotational motions. Okay, so for you to produce a moment, you need to make sure that force need to be perpendicular with the level arm. So D here is a level arm. Okay, so that's the rule first. That the first rule that you need to understand. For you to produce a moment, you need to make sure that your force perpendicular to the level arm. Okay, so you so there's a one what we call it as applications in the real life, which example, if I draw a door, and then we have a doorknob here, and then I put a hinge over here. So what happened is when I apply force perpendicular to level arm or D, what happened is this door going to move in a semicircular motions, which means that it obey the rules for the moment, which force need to be perpendicular to the level arm. So what if I apply force parallel to the level arm? Is there any movement? No, definitely no. Okay, means that the door not going to be open in the rotational motions, so because the force is parallel to the level arm, and you need to make sure that the force perpendicular to the level arm, then what happen is going to move in a circular motion. Okay, so the formula for the moment is moment equals to force need to be perpendicular to the level arm. It can be level arm perpendicular to the force. Either one is still produce moment, or we can actually say that it still produce a rotational motion. Okay, and the unit for moment is Newton dot meter, or there's a textbook actually mentioned meter dot Newton. It's basically the same thing. Okay, but here I want to emphasize that for you to produce a moment or torque, okay, you need to make sure that your force always be perpendicular to the level arm. Okay, so this is one of the example, okay, which means that you can see that when you apply force perpendicular to the level arm, so this is your level arm, what happen is going to rotate this screw. Okay, so this is one of the applications of the moment. Okay, so let's proceed to the next one. Okay, so I'm going to show you what exactly mean by moment. Okay, so you can see that you have you are going to use your hand, which is your hand going to be your axis of rotations. Okay, so this is axis of rotations. Okay, so this is going to be your level arm. So what happened is when you apply force perpendicular to the level arm, is going to move in circular motion. Okay, so your hand going to be your axis of rotation, so which means that you need to look at the questions. If the question put your hinge at the right side, so you need to put at the right side. If your hinge put the right at the left side, then you need to put at the left side, because it's going to give you a different in terms of clockwise and anti-clockwise. Okay, so this, okay, example, if I put here, this is my axis for rotations, and I applied it perpendicular, so what happened is going to move in rotational motion. However, if I apply force parallel here to the level arm, what happening is not going to move in rotational motion. Okay, so got it? Okay, so your this one I call is a magic pen, but it's a very not, it's a magic pen. This is like a very practical way for you to decide your directions of clockwise and anti-clockwise. Okay, okay, but there are certain situations where your force is not perpendicular to the level arm. Okay, so I give you the example. If you have this one beam, okay, and then you have hinge over here. Okay, hinge going to be this kind of symbol. Okay, hinge is basically an axis. Okay, if you have an axis, definitely you are going to rotate in circular motions. Okay, your axis going to be, okay, your axis going to be, okay, I put it as A. Okay, and then what happen if you apply force not perpendicular but with some angle? Okay, example, I put here angle is 20 degree, apply force 200 Newton. Okay, so what happened here is there any rotational moment? Is there any moment? Is there any rotational motion? Is there any moment? Definitely is going to have, but we need to change a little bit the diagram. Okay, so when you have a beam and then your force is not that perpendicular, you need to resolve the force, which means that you need to put it in the x-axis and y-axis. So means that here is going to be y-axis, and this is going to be y-axis, and this is x-axis. Okay, so when I draw it back, so I'm going, okay, make sure that your force always be outward. Okay, always be outward, and this is 20 degree, and then you make sure that you resolve the force. So here going to be 2000 sine 20 degree. Why it becomes sine? Because angle touch x-axis. And then you have another one which is 2000 cos 20 degree. Okay, your hinge, okay, when it comes to your hinge, okay, I put it here. Okay, so which one going to produce a moment, x-axis or y-axis? Definitely is going to be y-axis. Why? Is because of this one actually perpendicular to the level arm. Okay, you can see that this is y, perpendicular to the level arm, so that's the reason why the moment can actually produce if it's perpendicular. Okay, please take a note, it doesn't mean that all time only for y-axis. It depends on the situation of the questions, but here the things that you need to understand, you need to find the force perpendicular to the level arm. Okay, so here force is perpendicular to the level arm, then you get moment. So moment here going to be, force is 2000 sine 20 degree, and then you multiply with the level arm. Example, your level arm from force up until axis is 4.0 meter. You multiply by 4.0, then you get the answer, which the unit going to be Newton meter, or sometimes in your book is going to put as a meter Newton. It's basically the same thing. Okay, what if you have a, okay, this is one method. Another method you can actually use is, but this one you can use if you really understand, but when you go for physics one, this one going to help you a lot. But it's okay for you to know the method, the first method, but second method I'm going to show to you because there are certain students that maybe want to know the second method. Okay, example, I use the same picture. Okay, so you have force here. Okay, now I'm going to put it outward 20 degree, and I put hinge over here. Okay, so before this, we resolve the force. Okay, now I don't want to resolve the force. I want to use this force 2000 Newton, but I want to resolve the level arm. Okay, this is your level arm. Okay, it need to be either one, whether you resolve force or you resolve level arm. Okay, it cannot be both resolve. Okay, please take note, when you want to use this moment, it can be either one, whether you resolve force, which is method 1, or you can actually use the second method where you resolve level arm. Okay, when you resolve level arm here, you need to find a new level arm. Why? Because as you can see that your old level arm doesn't perpendicular with the force. Okay, this one definitely 20 degree. You need to find the level arm that 90 degree with the force. So how to do that? Okay, so it means that you, okay, here, okay, you put the hinge over here. Okay, so is okay, so I extend my force a little bit longer. Okay, so right now I'm going to find the new level arm that perpendicular to the force. So I think, okay, maybe I need to extend a little bit. So this one going to be perpendicular with your force, so this is going to be your new level arm. Why? Because force and new level arm perpendicular to each other. Okay, I didn't resolve the force, but I find a new level arm. Okay, you cannot use the old level arm because it's not perpendicular. So what happened here is, okay, example, I give it to you. Here is 4 meter, and here I give the force is 2000 Newton. Okay, so for me to find the new level arm, I need to use Pythagoras theorem, where my new level arm going to be, okay, so you need to make a calculation here. So definitely I need to find the new level arm here. So I'm going to use sine theta, opposite over hypotenuse, sine 20. My opposite going to be this one. This is adjacent and this is my hypotenuse. Okay, yeah, so I'm going to get opposite is, I didn't know the opposite, right? Okay, so this is 0.0. So my opposite, my new level arm going to be sine 20 times 4. So you are going to get 1.368 meter. Okay, so now if you want to find the moment, so definitely you're going to put m equals to force times distance. So your force going to be 2000. Okay, because you are not going to resolve the force, which means that there will be no sine or cos, and then you multiply by 1.368. So you are going to get 2736 Newton meter. So let's prove with the first method whether you're going to get the same answer or not. So 2000 sine 20 times 4, so you are going to get this one also 2736. Okay, so which means that you can use either method, whether you use method 1 or you use method 2. Okay, but method 1 is about resolve force, you stay with the level arm. Okay, and then the second method is about you need to find a new level arm, and then you didn't resolve the force. Okay, but the method 2 is quite hard for you to understand, so I encourage students to stick first with the first method, and when you go to the physics 1, it's better for you to know both method. Okay, because both method have their advantage. Okay, so okay, the thing here you need to be understand, when it comes to the level arm, okay, you need to make sure that all your, whether it's new or your old level arm, going to stick to only one axis. So this is your new lever arm, so all the forces going to connect it with the lever arm that have this axis only. Make sure that when you find the new lever arm, you need to make sure that it's connected to the new connected to the axis. Okay, so I'm going to show it to you. What does it mean? Okay, wait, okay, this one. Okay, example, if you have like 2 or 3 forces, okay, 2 or 3 forces, okay. So example, you have here 20 degree, you have 2000, and then you have another force here. So here I'm going to draw it outside. So maybe this is 5000, and then you have another force which is like this. Maybe this is theta is 10,000 with the 1000 Newton. Okay, so I'm going to extend a little bit here. Wait. Okay, here. So pump. So this is my hinge. Okay. So when it comes to this kind of questions, okay, you can see that if you want to use the first method, okay, the first method is about you resolve force. Okay, you resolve force. Okay, so I'm going to show you how to do it. Okay, right now means that when I resolve force, I didn't have to think about the new lever arm, which means that my new lever arm going to be this one. Okay, my lever arm. Okay, I'm only use this one lever arm to multiply with all the forces. Okay, so when you have moment, okay, net moment, it means that you need to add up everything. Okay, so how to decide positive and negative? Okay, you need to, okay, when it comes to moment, the only thing that you need to think is about clockwise or anti-clockwise. Okay, clockwise and anti-clockwise. Okay, moment is about rotational motion. That's the reason why you need to only focus clockwise and anti-clockwise. Okay, here is up to you. It's arbitrary. It means that you can choose clockwise as positive or clockwise as negative. But I think most students are going to choose this one as a positive and anti-clockwise as a negative. It's okay. If you want to vice versa, is also acceptable. You are going to get the same answer. Okay, so now I'm going to resolve force first. Okay, it's better for you to show your resolve because it's it's definitely going to it's definitely to make sure that you didn't do a careless mistake. Okay, so that's the reason why I encourage students to show the resolve force. Okay, because you can actually see that whether it's moving to the right, to the left, but now we only focus on clockwise or anti-clockwise. Okay, so you can see that we have 3 forces. We have 2000 Newton, we have 5000 Newton, we have 1000 Newton. Okay, there's 2 forces that you need to resolve, which is 2000 and 1000. Okay, so which axis that going to be perpendicular to your lever arm? So this is your lever arm. Which axis for 2000 is going to be? Yes, very good. Is going to be y-axis. So here, for you to produce a lever arm, is going to be 2000 sine 20 degree. Okay, positive or negative? Okay, so how to do that? Okay, you take, okay, so it's moving in what? Clockwise or anti-clockwise? Your hinge is in this part. Your hinge in this part. So, your axis, your 2000 going to move in anti-clockwise motion. Okay, so how to do that? Okay, like I mentioned in my previous video, you use your hand as axis. Make sure your hand axis, if example your axis to the left, you hold your hand to the left and then you apply force. Okay, right now it apply force upward, so you can actually see that it's moving. So it's going to move in anti-clockwise motion. Okay, so how to do that? Okay, you take one pen, okay, and then you hold your pen, and when you hold, your hand going to be your axis. Okay, so now your axis is basically at the left side, so you hold exactly as the diagram show, which is your axis at the left side, and then you apply force to the right side, which is perpendicular, which is upward. So you can actually see that is moving to anti-clockwise motion. Okay, that's how you do it. So here, when you put anti-clockwise motion, is going to be what? Is going to be negative value. Okay, how about 5,000? Do you need to resolve? You don't have to, because why? 5,000 already produced the moment. Okay, because it's definitely perpendicular to the level arm. Okay, so your 5,000, okay, I put here, okay, I put the first one. The moment one is 2,000 sine 20. So you are going to get this one negative answer, Newton a meter. And the moment 2 is 5,000. Oh, sorry, you need to multiply with the level arm. Okay, so example, I give you a level arm here is, okay, example, I give it here to here is 4.0 meter, and 5,000 to the axis is 2.0 meter, and this one going to be only 1.0. Okay, this is example only. Okay, sorry. Okay, so 2,000 sine 20, you need to multiply by 4. So you are going to get 2,000 sine 20 times 4. You are going to get 2736. Why is it become negative? Because it's anti-clockwise. Please take note, you only focus moment for clockwise and anti-clockwise. Okay, for moment to 5,000, okay, you need to multiply by level arm, which is now your level arm going to be 2 meter. Okay, so it's going to be times 2. So 5,000 times 2, you get 10,000 Newton meter. Okay, clockwise or anti-clockwise? Yes, it's going to be anti-clockwise. Then you need to put the negative over there. Okay, next, for the moment 3, which is 1,000 over there. Okay, which one that going to produce a moment? Y-axis or X-axis? Yes, very good. It should be Y-axis. Because of why? Perpendicular to the level arm. Okay, so it should be this one. Okay, so now, okay, so I'm going to put it here. So it's going to be 1,000 sine or cos. Yes, because my angle touch 10 degree angle touch x-axis. That's why my y-axis is going to be sine. Okay, multiply by level arm, which is 1 meter. Okay, 1,000 times sine 10. You're going to get 173.6 Newton meter. Clockwise or anti-clockwise? Okay, so when you hold your hand going to be your hinge, and then it's still pointed upward, so means that it's going to be anti-clockwise, so it's still negative over here. Okay, that's how you do it if you want to resolve force. But I encourage students to resolve force instead of you need to find a new level arm, because it's quite confusing. What I mean here is example. Okay, example, I just showed the example with that number. Okay, you have one force here. So if I want to resolve, if I want to find the new level arm, I need to take care that all my new level arm going to connect with the same hinge. All my new level arm should be connected with the same hinge. Okay, I cannot build a new hinge. My new level arm should be connected to the new hinge. Okay, so this one, I extend this one a little bit like I showed you before. So this is going to be my new level arm for the first one. So new level arm for F1. Okay, how about 5,000? Okay, how about 5,000? Okay, I show in the separate diagram. Hinge. Okay, for the 5,000 it's practically easy because it's only y-axis. So this is my level arm, so I don't have to find a new one because it's definitely perpendicular. So I can actually use 2 meter as the F2 level arm. Okay, how about 1000? Okay, 1000, because you have force that basically need to resolve, but I don't want to resolve, I need to find a new level arm, so I draw in a separate picture. So this is my hinge. Okay, my force is in this diagram, in this direction. So for me to find a new level arm, I need to make sure that I connected to the same hinge, because this one I connected to the hinge, this one also I connected to the same hinge, definitely this one I need to connect it to the same hinge. So where is the directions of the new level arm for the F3? Where is it? So it's definitely going to be, yeah, I think. Okay, so this is quite tricky for the F3. Okay, so you need to find the new level arm. I think somewhere it should be here. Okay, sorry, it should be here. Yeah. Okay, yeah. Okay, so this is your new level arm. Okay, it's going to connect it with the same as this. Okay, yeah, or maybe you can actually find it here. Okay, I think this one also acceptable, but make sure it's perpendicular. Okay, then you are going to get the new level arm. But but like I mentioned before, it's quite hard for you to find the new level arm. So that's why for your level, I think it's better for you to stick to just resolve force and you just use the level arm. It's pretty easy like in compare with the method 2. Okay, let's proceed to the next one. Okay, this is what I'm talking, this is what I mentioned before, where here is about you find a new level arm. Okay, so this is your new level arm. Okay, and because it's what, it's 90 degree to the force, you don't have to resolve the force, but you need to find the level arm. But as I mentioned before, it's quite hard for you to find it. And please take note, your force is also we call as a line of actions. Okay, so line of action, which is force, need to be perpendicular to the level arm. That's the things that you need to understand where you need to find the moment. Okay, so this example, pushing a door closer to the axis of rotation make it difficult to open the door. Okay, so like I think you already learned in SPM before. Okay, when you apply force quite close to the hinge, what happens is your force going to be higher. Okay, because you decrease the distance, right? Okay, that's the reason why your knob is basically built far away, because this one, to make sure that your force is going to be minimum and you maximize the level arm, so you are going to get the same value of moment like you apply force close to the hinge. Okay, this one you already learned in SPM. Okay, but that's when I think you call it fulcrum, but here we call hinge or axis of rotation. Okay, so this one, like I mentioned again, okay, pushing into the hinge make it difficult to open. Pushing into the hinge, it means that if you apply force parallel to the hinge, okay, so definitely you are not going to open the door. So this is what happened. Okay, so you have force that basically looks like this, which definitely you need to resolve force. So you are going to resolve it into Fs and Fy and choose force that perpendicular to your level arm. Okay, got it? Okay, let's proceed to the next one. Okay, what does it mean by couple? Okay, couple is not a normal couple like, like girlfriend and boyfriend. Is definitely a different thing. Okay, so I can give you example. A couple is something like when you drive the car, okay, and then you have you have a steering wheel. Okay, you can actually see that when you put your hands at the steering wheel, when you want to make a rotational motions, is going to move. Okay, your left hand example. Okay, if you want to move to the right, so you can actually see that both hands are moving in different direction, right? So one going to be like that and one going to be like that. So when it's moving in different direction, you can actually see that this is what we call couple. You have two forces, doesn't share the same line of action, okay, which means that here this is line of action and this is another line of action. It doesn't share the line of action. There is force. You have two forces, same magnitude, moving in different direction. That's what we call as a couple. Okay, but mostly for your questions, you doesn't have any couple questions because the level is quite high. But you need to know, you need to understand what is couple. It's actually appear in your calculation, but it doesn't that important. Okay, for now. And the question mostly is about beam. It's not about like you have a circular object like that. Okay. Okay, I repeat, couple is basically you have two parallel forces, doesn't share the same line of action, same magnitude and different direction. Okay, so that's what we call as a couple. Okay. Okay. Okay, so this is yes, this is basically like one of the example of the couple, which means that you have two parallel forces, doesn't share the line of action. Okay, please take note, line of action means force. Okay, if your forces share the line of action, so basically it should be here. So but here the couple doesn't share the line of action, separate by a level arm, and that's what we call as a forces. Okay, why here is become positive? As you can see that this one moving in clockwise and this one moving in clockwise. Why? Because force is perpendicular to the level arm. That's why you get force 1 times distance 1 plus force 2 times distance 2, then you get 2FD, which means that you need to find what? Net moment. Okay. Okay, so before we proceed with the calculation, the first thing that you need to understand when it comes to the Newton's law, we need to draw a free body diagram, or other names we call as a force body diagram. Okay, what does it mean by free body diagram or force body diagram? Free body diagram or force body diagram, or I call it as FBD, is basically you need to draw only forces. Okay, you need to detect, you need to recognize the directions of the forces, and your diagram should be forces and the beam only. Okay, so example like, okay, example, okay, you have here example, I put like, okay, this is hinge, okay, hinge, and then I put one object here. Okay, so basically this beam going to be your main character, which means that you need to show all the forces acting on the beam. Okay, which means that you need to show all the forces acting on the beam. Okay, because now the question, we need to find moment at the beam. Okay, I'm going to explain after this why we need to find the moment at the beam. Okay. Okay, so you have this one object. So based on your SPM physics knowledge, if I'm not mistaken, okay, you are going to apply normal force, or I didn't know the name before this, you call it as a reaction. Okay, so the normal force going to be upward. Okay, upward to what? This object, this small sphere object, apply forces upward to the beam. Okay, because right now I said that your beam going to be your main character. Okay, how about hinge? Okay, as you can see that when it comes to hinge, you are going to have two forces, X component and Y component. How to decide the directions, I'm going to explain later. Okay, but here your hinge going to have two forces. Okay, please take note, when it comes to hinge, you are going to have two forces. Okay, so I put it as a R. Okay, this is R, this is F, RY and RS. Okay, directions, I'm going to show you later how to decide the directions for the hinge. Basically, this is your free body diagram, which means that you show only forces. Okay, So means that when it comes to I ask you to draw the FBD and you get marks for the FBD, you need to show only for the forces. So going to be here is your F. Okay, and then here is RY and RS. So this is we call as a FBD. You need to show only forces acting on the beam. Okay, you need to make sure that you put arrow because arrow represent direction, because right now we discuss about vector, not scalar. Okay, let's proceed. Okay, so let's recall a certain situations and which directions the force going to be at. Upward, downward, left, right, with some angle. Okay, so example, if you have one object, okay, example lah, you have this one box, and this box going to be your main character. When I say about main character, it means that you need to find all the forces acting on the main character. Okay, so and then you have the inclined plane. Okay, so when you draw the FBD, you need to show only forces. So what is the force acting on the box from the inclined plane? Parallel, perpendicular, left, right, up, down? It should be perpendicular to the face of the inclined plane. Okay, I repeat, when it comes to the inclined plane, force need to be perpendicular to the surface. Perpendicular. So I draw it back. Box going to feel forces perpendicular to the inclined plane. Okay, and that's what you get from this picture. Okay, you have, okay, your main character going to be a sphere. Okay, so inclined plane going to act perpendicular, and that's the reason why you're going to get perpendicular. Make sure that forces is better for you to draw outward. Okay, so example, if I put beam on the inclined plane, so where is the directions of the forces acting on the beam because of the inclined plane? And I put a hinge here. Where? So the inclined plane going to be perpendicular to the inclined plane, and forces at the hinge, I'm going to show you later the directions, is going to have X and Y. So this is going to be RS, this is going to be RY. So it's better for you to draw back. This is your beam and this is your force. If example you have angle here, so zigzag, you are going to get angle here and 90, and it should be 90 degree here. So this one going to be 90 degree minus theta. So this angle is about 90 degree minus theta. Okay, and then for your hinge, you are going to get RS and RY. So this is the FBD. Okay, which means that you show only forces. Okay, what about if we have tension? Tension is basically one of the force. Okay, so you have one rope or string, and then you have one box here. Example, attach this to this one, to the wall or anything. Okay, so please take note, when it comes to tensional force, it's always be outward from the body, from the main character. It's always be outward from the main character. So when you draw the FBD, it's going to be FT, and this is your main character. Okay, always be outward when it comes to tensional force. Okay, yes, okay, this one. Okay, if you have object, any object, a roller, ball, square, or anything. Okay, example, I have a beam and I have this one triangle things. This is not hinge. Hinge only be represented by this symbol. So where is directions of the forces acting on the beam because of these triangle things? Yes, draw it back. Is going to be, yes, it's going to be upward. Okay, because of what? This triangle acting force on the beam. Your beam going to be your main character. Take note, we only find forces on the main character, okay? Because mostly for the beam, the one going to be the main character in your question. Okay. What about if you have hinge or pin? Like I mentioned before, your hinge or your pin going to have two forces, which is X component and Y component. And directions, I'm going to show you later. Basically, when it comes to the hinge, you need to decide the directions, not the questions, okay? But I'm going to explain later. So when you have a hinge, this is not FBD, you need to draw it back. Okay, so it's going to be RX, RY and RX. Oh, sorry. Okay. Okay, sorry, I think the previous one I showed that the RS is this one. Sorry, this is should be RY and this should be RX. Okay. Okay, so let's proceed to the next one. Okay. Okay, so this is the FBD for the support reaction. So this is the basically it shows you the directions of the forces when it comes to the hinge. Like I mentioned before, you have two directions, Fy and Fx. Example, if you have feet support and this beam basically attached to the wall, definitely they also have two forces, which is Fx and Fy. Okay, because it looks like a hinge but it doesn't represent hinge. Okay, basically when you have beam attached to the wall, you are still going to have two forces. Okay, so same goes as this one. You have inclined plane is going to attach perpendicular to the surface of the inclined plane, but mostly for the questions of the roller, I'm not going to give it to you because this is quite high level. Okay, but you need to understand that when you have inclined plane and you have object, which is your main character, is always perpendicular to the surface of the inclined plane. Okay. Okay, so this one, okay, I'm going to show you part by part, which definitely after this we are going to merge everything and then we are going to do some questions. Okay, so the FBD for the distributed forces. Okay, so example, if the question state you have the beam has a mass of 5,000, beam has a mass of 50 kilo. Okay, this one definitely SI unit. If the question state 50 slug, then it's going to be USCS system. If the question state 50 pound mass, it's going to be engineering system. Okay, for these questions, you need to be extra careful with the units. Please make sure that the units, you follow the units in the question. Okay, I think I'm not going to give it to you, the questions that you need to convert the units. No, I'm going to give it to you, but I'm going to show you at the back, but it's not like a full conversion unit, it's just a half of it of the conversion unit. Okay, example, if you have beam 50 kilogram, okay, please take note, when it comes to the FBD, you need to show only force. And 50 kilogram is not force, it's actually mass. Okay, if the question state the beam has a 50 kilogram, you need to convert this thing into weight, or the other name is gravitational force. So use the formula that I teach you before, the GL and the GC. So F equals to mgl over GC. Okay, so it's going to be 50 kilogram times GL going to be 9.807 meter per second square, and then GC going to be 1.0 kilogram meter per second square over Newton. You find the force first. So it's going to be 50 times 9.807 is going to be 490.4. Please take 3 or 4 significant figure for Newton. Okay. Okay. If the question state beam has a mass, what if, okay, where is the directions of the forces acting on the beam? When it comes to mass, okay, you learned before center of mass. So definitely is going to be at the center. Yes. Okay. Okay, what if the question state it has mass distribution? Okay, it's quite different, okay? Okay, this is mass. What if the question state about mass distribution? Okay. A mass distribution, mostly the question going to be state if the beam has a mass of 50 kilogram per meter. 50 kilogram per meter. So definitely there is going to be mass distribution. So what does it mean by kilogram per meter? It means that in one beam, every 1 meter is 50 kilo, 50 kilo, 50 kilo, 50 kilo, 50 kilo, 50 kilo, 50 kilo. So every 1 meter have 50 kilogram. So you need to find only one mass, only one weight at the center. So how to do this question? Okay, you need, please take note, FBD is about force. You need to convert into force. Okay, so but when it comes to the mass distribution, the first thing first that you need to do is 50 kilo per meter. You multiply with the length of the beam. Full length of the beam. So example, if your full length of the beam is 100 meter, so 50 kilogram per meter multiplied by full length of the beam. Cancel the meter, then you get 5,000 kilogram. This is not weight. This is not gravitational force. You need to change into gravitational force or weight, which means that you need to use what? F equals to mgl over gc, because the question state in SI unit, so it need to be F equals to 5,000 kilogram times 9.807 a meter per second square over gc is what? 1.0 kilogram meter per second square over Newton. So you are going to get 5,000 times 9.807. The answer going to be 59035. Unit is Newton. Okay, so you can see the difference between mass distribution and mass. Okay, so and then where is the positions for the mass distribution? Basically the same thing, which is at the center of the beam. So at the center of the beam, this is going to be 49035 Newton at the center. Okay, because center of mass, or the other name is center of gravity. Okay, so you need to show the calculation. If I ask you for the mass, if I state the beam has a mass of 50 kilogram, or I state the beam has a mass distribution of 50 kilogram per meter, you need to show the working step. This is going to be marks. Okay, let's proceed to the next one. Okay, so now the question asks you to draw all the forces acting on the body. Okay, so this is, and then you just resolve of the forces. Okay. Okay, so the directions of the forces for this one going to be, okay, I draw it first. Okay, this is tension, cable have a tension, and then you have this one beam here. Okay, so your main character going to be the sphere. Okay, so make sure that you draw a correct free body diagram. If example your free body diagram wrong, what happened is your calculation also wrong, so you're going to lose like 12 or 14 marks. Okay, so I draw it back. I have a sphere here. Okay, tension cable. Yeah, remember tension always be outward, so that's the reason why I'm going to draw it. Tension there, FT, and the angle going to be 60 degree because zigzag. Then you get 60 degree here. Okay, and then this one, this object also apply force, which is perpendicular. It looks like a inclined plane, and please take note, is always perpendicular to the surface of the is always perpendicular to the surface. So it's going to be in which direction? It's going to be Okay, example, I put it here. Okay, I put it like this is y and this is x, and it should be somewhere here. So it's going to be 45 degree at this part. Okay, so 45 degree at this part. So here, if you have forces here, okay, example, I show it to you. The 45 degree is basically here also. Okay, so when you have force here, is going to be 45 degree here. Okay, yes. Okay, so that's how you do it. Okay, what else? Do you have any forces other than that? Okay, there's another one, which is, okay, in this world we have that force. Okay, when you live in earth, you are going to feel that force, which is what? Weight. Okay, so weight or gravitational force always be downward. Okay, I repeat, always be downward. So it's going to be always be downward from the center of the mass. So it's going to be here is the gravitational force. So this is what we call as a FBD, where you need to show only force. Okay, so I show it at the back. Okay, I show it at the back for you, this one. Okay, so this is basically the way that you need to draw, but this one is quite wrong. You need to make sure that you draw it always be outward. Okay, always be outward. So 45 degree going to be in these directions. Okay, and then you get marks if you draw a complete free body diagram. Okay, let's proceed to the next one. Okay, so like I mentioned before, why we need to draw the FBD, why we need to find the moment, is because there's one condition we call as the condition for equilibrium. Okay, what does it mean by equilibrium? Equilibrium, it means that balance. Okay, so it means that, as you can see, in one object, why the object at rest, why the object stay at rest even though there's a lot of forces over there, is because of all the forces balance out each other, and that's the reason why the object will be in equilibrium. Okay, like this one object, which is books. You put it on the table but it doesn't move. Why? Because the normal force here, okay, please take note, books going to be your main character. This books going to be balanced by the gravitational force downward. So that's the reason why it's going to be equilibrium. Okay, so what is the condition for equilibrium? Okay, so you need to make sure that we have three conditions to make sure that the object equilibrium. The first thing that you need to understand that all the forces in x component should be 0, which means that right need to be balanced with the left, or left need to be balanced with the right. Okay, then you get 0. And then all the forces in Fy should be equals to 0. Okay, up and down balance out each other, then you are going to get 0 for that. Okay, and then the last one, to make sure that the object in equilibrium, is sum of moment equal to 0, which means that all the forces in moving in clockwise should be balanced with the anti-clockwise. Okay, so if all these three things complete, then the object will be in equilibrium. Okay, so Fs is about right and left, Fy is about up and down, and moment is about anti-clockwise and clockwise. Okay, please make sure that you differentiate, and please take note. Okay, so we are going to use all these three rules in our calculation after this, which means that we need to find the moment equal to 0. We need to find the we need to use Fy equal to 0 and Fs equal to 0. And please take note, forces exist. Forces not 0. Net force equal to 0. Okay, please take note, it should be net force equal to 0, not forces. Okay, you have force 1, force F1, F2, F3, F4, but the net force going to be 0, then it's going to be equilibrium. Okay, so this is the step for you to solve the problems when it comes to the questions of equilibrium. First thing first, I ask you to draw a free body diagram. Okay, once you've okay, because if you wrongly draw a free body diagram, what happen is your calculation is going to be wrong. Okay, make sure that you have all the forces completely, and then you start with the calculation. That's the steps that you need to follow. Okay, and make sure that the directions of force is correct. Okay, okay, please take note when it comes to the hinge. Okay, I forget to mention about directions of the hinge. Okay, as I mentioned before, we have two directions when it comes to the hinge, X and Y. But where is the direction? Okay, even I didn't know the directions of the hinge. Okay, why? Okay, so you can see that when you have all the forces here, okay, you have F1, F2, and F3. Okay, so means that what is the function of the hinge? Hinge going to give a force that balance F1, F2, and F3. Okay, hinge going to give a force that balance F1, F2, F3 to make sure beam going to be equilibrium. Okay, so where is the directions? That's the reason why you need to do a calculations. Okay, so for the hinge, you need to assume. Okay, you make an assumption. Okay, it can be ry upward, rx to the right. It can be ry upward, rx to the left. It can be it can be ry downward and rx to the right. It can be ry downward, rx to the left. Okay, which direction is correct? No answer. When you finish the calculation, if you get your force ry is negative, it means that your answer direction is wrong. Your answer, your direction is wrong. You don't have to correct. You don't have to make a corrections at your diagram. Just give a statement. Okay, if you get ry negative, it means that the direction should be downward or upward. Okay, example. Okay, I show you the example first. Okay, example. Okay, you have beam. Okay, this one I did it without the number. After this, I'm going to show you the number. Okay, so here you have a beam, and then you have all the forces. Example, okay, like this is force. Okay, so basically what happened here, when you have force and then you have hinge here. Okay, so you are going to use, you need to resolve all the forces and then categorize into x component, y component, and moment. Okay, so you have fx equals to 0, fy equals to 0, and the last one, moment, equals to 0. So for the hinge, we need to assume first. Okay, I'm going to assume that my directions of hinge, I assume. Okay, I didn't know whether it's correct or wrong, so I put it as ry, and then I put it as a left is rs. Okay, so what happened here is when the hinge, I assume downward, upward, it means that it can balance all the forces in fy component. So like this, so means that supposedly if my ry is correct, the fy should be 0. So if I get my ry is negative, what does it mean? It means that my directions of forces is wrong. It should be downward. Downward doesn't mean negative. Negative here means wrong. Positive means right. Okay. Yes. Okay. Example. Okay. I put it. Okay. Example. I put it. My assumptions as ry is downward and rs is to the left, and I get ry negative. My answer is wrong. My reaction force in ry, if I assume downward, it doesn't balance all the forces, which means that my assumption is wrong. So means that I need to give a statement. You don't have to fix your answer, your diagram. You just give your statement, the directions of ry, direction of Ry should be upward. Okay, so negative here, if you get, is wrong. Doesn't mean downward or left. It means wrong. If you get positive, it means right. Okay, so what if I get Rs is positive? Which means that my answer Rs is correct. Which means that if I assume hinge for the Rs to the left is going to balance all the S component for other forces, then it means that it's going to be equilibrium. Okay, so I repeat again. If you get Ry negative or Rs negative, negative means wrong. It doesn't mean left or downward. It means wrong. If you get positive, it means right. If you get negative, you need to give a statement, so the direction should be opposite to what that you assume. Okay, so example, if I get Rs negative, yes, for this one, what does it mean? The directions of the Rs should be to the right, then it's going to balance all the forces in S component. Okay, so here your Rs, your negative means wrong, your positive means right. That's the reason why for the hinge we didn't know the answer yet, so we need to assume from these four choices of directions, whether your Ry can be upward or downward, or Rs can be left or right. Okay, but basically what happened here is at the end all the answer going to be the same answer. Okay, that's how you do it. That's why you need to assume. Please, after this, when I do the questions, you use different assumption. Don't use my assumption, and you are going to see that both our answer going to get the same thing. Okay, which means that at the end we are going to get the correct direction for the hinge. Okay, so let's start with the first one when it comes to the calculations. Okay, the question asks you to construct a free body diagram for the beam shown in the figure. There is a 5.50 kilonewton meter clockwise moment applied at the right end of the beam. The beam has a mass of 48 kilogram. Okay, for this one, I just want to cancel this question first. This one, okay, because this one I'm going to show you step by step. We do the simple question first, and after this we are going to proceed with the hardest part. Okay, so first thing first, when you have the question, you need to draw a free body diagram. Okay, means that you need to show only forces. Okay, so you draw a free body diagram. Okay, then you have 850. Okay, make sure that always be upward. Okay, and this one is SI unit. Okay, this one, where is the directions of the forces acting on the beam? Is going to be perpendicular, which is going to be upward, so you put it as a FB. Okay, like that. Okay, example, I give this so FB, we didn't know the answer yet. Okay, then we find the hinge. Okay, the hinge, like I mentioned before, you need to assume the directions of the forces. So now I'm going to assume my directions of the forces at the hinge going to be maybe downward. So I put it as a AY, and maybe to the right. I didn't know the answer yet. My positive and negative going to be decide after I'm doing my calculations. Okay, and it's better for you to put all the level arm value. Is much easy, plus going to avoid you the careless mistake. Okay, so this is going to be 2 meter, and this is going to be 1 meter. Okay, please take note, at the hinge there will be no moment. Why? Okay, as you can see that moment, okay, for us to calculate the moment, okay, we have force times D, level arm. The level arm going to be measured from moment from the hinge up until the force. Okay, level arm going to be measured from the hinge up until force or line of action. So if I put, so your hinge going to be your 0 point, going to be your first point, you're going to be your starting point. So if you put forces here and your level arm is at the hinge, so your level arm going to be 0, because your level arm going to be measured from hinge up until force. hinge up until force. That's the reason why at the hinge, it doesn't have any moment. So moment will be 0. Okay, please take note about that. Okay, so now I encourage you to use first moment equals to 0, which is net moment equal to 0. Okay, which means that you only focus on clockwise and anti-clockwise. Okay, and please take note, at hinge, your moment is 0. Okay, so there's only two forces here, which is basically easy, which is 850 and FB. So right now, you need to find the missing forces, which means that, okay, the question asks you to find what is the value of B and what is the value of A to make sure that this beam in equilibrium. Okay, I repeat, the question asks you what is the value of forces in B and what is the value of forces in A that needs to be to make sure that the beam in equilibrium. Okay, so that's why here we have one unknown. Okay, so you can actually use moment there. So we focus only clockwise and anti-clockwise. Okay, so 850 Newton. Okay, 850 is going to be clockwise or anti-clockwise. Okay, 850 Newton going to be clockwise motion. So when I put as a clockwise here, I'm going to put the reminder for me, which is anti-clockwise is negative, clockwise is positive. So what happened is, for the 850, when I hold my pen, and my hand going to be the axis of rotation, so I apply force downward, is going to move in the clockwise motion. So I'm going to put it as a positive 850. Moment is about, you need to multiply with the level arm. So 850 multiply with the level arm, which is 2 and 6. So it's going to get 8. Okay, how about FB? Is moving in clockwise or anti-clockwise? So it's going to move in anti-clockwise. So my anti-clockwise here is negative. So it's going to be negative FB. And what is the value for the level arm? 6 meter. Equals to what? 0. Which means that we want to find the FB that going to be a value to make sure that the beam will be equilibrium for clockwise and anti-clockwise. So you can actually get FB, right? So for FB, you are going to get 4 times 8 divided by 6. You are going to get 1133 Newton. Okay. Okay. So your FB going to be 1133. So means that this value going to balance the value for other forces to make sure that clockwise and anti-clockwise balance out each other. Okay, let's proceed with the moment with the Fs equal to 0 of Fy equal to 0. You can actually start with the Fs or Fy. It's up to you. So now I'm going to put sum of Fy first. Sum of Fy equal to 0. Okay, when it comes to the Fy is not moment. Fy means that you only focus force. Means that you don't have to multiply with the level arm. Okay, you only focus force. It means that you don't have to multiply with the level arm, which means that when it comes to the Fy, the things that you need to only focus is upward and downward. Okay, upward and downward. It's not about clockwise or anti-clockwise anymore. It's about upward and downward. Okay, so mostly students going to put upward as a positive and downward as a negative. Okay, so now we focus only force, which means that we need to focus only Fy, not Fs. Okay, so now 850 is definitely in y-axis, so it's downward, so it should be negative 850. And Fb is positive upward here. Okay, you just put the answer, so it's going to be plus 1133. And for the hinge, you have force over there. Okay, it's not moment, it's force. Okay, so Ay downward. Okay, I assume my Ay is downward, so downward is negative, so I put it as negative Ay, and it will be equal to what? It will be equal to 0, because we want to find the value for equilibrium in x-axis. So your AY, you are going to get positive or negative. Okay, so 850. Okay, so AY here, you are going to get positive 283 Newton. You don't have to write the positive over there, but I just want to show you. Okay, if you get positive, it means that the directions of the downward of your assumption is correct. So AY here, you assume correct. It should be downward, because when it comes to downward, it can balance all the forces for the FB and 850, and you get positive. It means correct direction. You don't have to give statement. Only negative you give a statement. Okay, next, we are not done yet. Okay, so we need to use another one, which is sum of forces in Fs equal to 0. Okay, so when it comes to the Fs, you need to only focus on right and left. Okay, so you only focus on right and left. Okay, so it means that we need to find forces that balance out for the x-axis. So students assume right is positive and left is negative. So okay, 850, there's no x-axis. FB, there's no x-axis, so maybe only on the hinge. So it means that here the questions, there's no forces that can balance, there's no forces that need to be balanced for the AS. Okay, so your AS going to be 0. Okay, that's the way that you need to do the questions. Basically, there's a few steps after that, but I'm going to show you for the next question. Okay, understand? Okay, let's proceed to the next one. Okay, so here I already give I highlight here. Okay, so if you get negative, it means the force is in the opposite direction. The force here is at hinge, which means that your assumption force. Okay, your assumption. Okay, please take note, you don't have to fix your diagram, you don't have to make a correction to your diagram. You just give a statement if you get negative. Okay, so this one, this question I think is quite easy. You can do it by yourself. I want to find the question that have x component. This one only have y component, and then but I'm going to show you how to draw a FBD. Okay, so this one is pretty easy. So for right now you have unknown at B and A, and the question asks you to find the reaction force. If the question state reaction force, it means that you need to find the magnitude and direction. Okay, if the question state reaction force, it means that you need to find the magnitude and direction. So where is the directions for the B applied to the beam? It's going to be upward. Okay, and then you have 38 kilonewtons, so make sure that your arrow always pointed upward. Okay, and then you have 7 kilonewton over here, so 7 power of 3, and then you have hinge over there, which means that you need to assume. So I assume that maybe it can be upward AY, and it can be to the right. I didn't know the answer yet, so for my calculations, if I get negative, it means wrong. If I get positive, it means right. So this is your FBD. Okay, but make sure that you write all the level arm there. Okay, yes. Okay, let's proceed to the next one. Okay, so this is the real questions that I'm going to ask you. Okay, so this is one of the questions that I'm going to ask you. Okay, so the question asks you to construct a free body diagram, and then please take note, I put it here, the beam has a uniform cross section and it's not weight distribution, it's actually mass distribution. Okay, of 6 kg per meter. Determine the resultant reaction forces at support A and reaction at B for the equilibrium condition. So when the question state equilibrium condition, it means that sum of M equal to 0, sum of Fx equals to 0, and sum of Fy equals to 0. Okay, so first thing first, when you have this kind of questions, you need to draw the FPD. Okay, you need to draw the FPD. So it means that here I'm just showing you the forces. First, for the A is going to be upward because the sphere here going to apply force to the beam, which is upward. Okay, and then hinge, I maybe assume by upward and bs to the left. Okay, I'm going to draw it clearly, and I'm going to show you step by step. Okay, so now we are going to draw an FPD for this kind of questions. Okay, so here, so yeah, there's the questions over there, so it's much easier for you to refer. Okay, so I'm going to start with the free body diagram first. Make sure that you draw it correctly and double check, make sure that you have all the forces needed. Okay, but here, as you can see that it's not weight, it should be mass. Okay, so you have 6 kilogram per meter. Okay, first thing first, I think it's better for me to find the forces of the mass first, which means that, oh my god, it should be 6.0 kilogram per meter. You need to multiply with what? With the full length of the beam. Okay, full length of the beam. Okay, so full length of the beam, you are going to get 28. It should be 39. So 39 meter. So here you are going to get, the value should be 6 times 39. You are going to get 234 kilogram. Okay, so then you use the F equals to mgl over gc for you to find weight or gravitational force. So it need to be 234 kilogram multiply with the gl is, this is SI unit, so 9.807 meter per second square over gc is 1.0 kilogram meter per second square over Newton. Okay, 607, then you are going to get 2295 Newton. Okay, next we are going to do the free body diagram. Okay, so here I draw a free body diagram. Okay, so means that now, okay, first thing first, at the hinge, okay, I want to assume, okay, I need to assume. Okay, so I'm going to assume is going to be, I didn't know, it's going to be by maybe upward and bs maybe to the right. I didn't know yet the answer. My calculation is going to prove it whether it's correct or wrong. Okay, and then 110 Newton. Okay, you have 4 and 6 here. You need to find the angle first. Okay, so the angle here going to be tangent 4 divided by 6. So you are going to get 33.7 degree. Okay, so 33.7 degrees, so it means that I'm going to get here 33.7. So it always be upward, and then I put 110 Newton over there, and it should be 33.7. Okay, next for A, the direction is definitely going to be upward. Okay, so here going to be upward. I put it as a A, or you can actually put it as a AY. Okay, because they only have one axis. Okay, next 6 is 0 Newton, so it's going to be like that, always be upward. 6 is 0 Newton. Okay, you need to find the angle for this one. Okay, you need to find the angle for this one. Okay, so the angle going to be tangent 3 by 1. So you are going to get this one is 71.5 or 71.6. Okay, so I get here, so I'm going to get, because it's zigzag, so it's going to be 71.6. degree. Okay, you are not done yet because you have this one, the mass distributions of the beam. So it's always be at what? At the center. Okay, make sure you draw it correctly. This one you need to put it up there. So this is 2295, my weight for the center of the beam, which is always be at the center. Okay, next you need to put all the level arms to make it easy for you to refer. 11 meter, and this one going to be 19 meter, and this one going to be 9 meter. Okay, once you're done with the FBD, double check everything. Okay, so now it's time for you to start with the calculations. Okay, so I'm going to start with the moment equals to 0. So I'm going to start moment equals to 0, which means that I need to focus only on clockwise and anti-clockwise. Okay, so is there any moment at the hinge? No. Okay, because your level arm, you are going to be measured from the hinge. That's the reason why there's no moment at the hinge. You don't have to, you can actually write 0, or you don't have to put it. It's okay. Okay, so now I'm going to resolve the forces. So this is like this and like this. Okay, so it's much easier for me to see the directions of the forces, which means that for the moment I need to find the force that perpendicular to the level arm. So definitely the one that perpendicular for 110 is y component, and for 660 also y component. Okay, yeah. Okay, like I mentioned before, it doesn't mean that your level your force that perpendicular always be y. It can be x, but it depends on the questions. But now you can actually see that most of it is y component. Okay, so proceed. Okay, so the B, okay, so at the hinge there will be no moment. So 110 going to be clockwise or anti-clockwise. Okay, so you're going to put your hand to the right side because it represents your axis of rotation. Okay, so you apply force downward, so you are going to get anti-clockwise, right? It should be negative over there. So it should be negative 110. Okay, sine or cos? It should be sine because the y component is the one that produce a moment. So it should be sine 33.7 degree multiply with the level arm. So level arm here going to be 11, right? Because from force up until hinge. So you're going to get here is 11. Okay, next AY. Okay, AY. Sorry, can AY. So AY definitely have a moment because the force is perpendicular to the level arm. So AY is clockwise or anti-clockwise? Is going to be clockwise. Okay, so plus AY, you multiply with the level arm. Okay, level arm going to be 19 plus 11. So you are going to get 30 over there. Okay. Okay. Next, 2295 Newton because its force is perpendicular to the level arm. So definitely you're going to have a moment. So is clockwise or anti-clockwise? It's going to be anti-clockwise. So I put here as a negative 2295 multiply with the level arm. Okay, please take note, when it comes to the mass distribution, always be at the center. So the total full length is 39. So you 39 divide by 2. Then you get 19.5. Okay, because this one always be at the center of mass. Okay. Okay, and then the last one is 660. So definitely I'm going to get the y component because that one is the perpendicular and produce moment. So it's going to be clockwise or anti-clockwise? It's going to be anti-clockwise. So I put it negative 660. Sine or cos? Angle touch SZ. So my y component going to be sine 71.6 degree multiply with the level arm, which is definitely 9 plus 19 plus 11. Then you get 39. Okay, equals to what? 0. So you can actually get AY, right? Okay, so right now find AY. Okay, so you are going to get 0 sine 33.7 plus 11 minus minus and answer minus 2295 times 19.5 minus 660 sine 71.6 times 39. So you are going to get 9 8 I'm going to get divide. Okay, so this one is going to be negative, but that will be positive. So you're going to get 69848, right? 48. So divide by 30. So supposedly your AY going to be 2328 positive 2328 Newton. Okay, so you already find the AY. So now that's the function of moment. Moment is basically for you to find the unknown. So if you have two unknown, you can put one as a 0 because at the hinge, at the axis of rotation, there will be no moment. So you can find another unknown. That's the reason why you need to use moment equal to 0 first before you proceed with the Fs and Fy. Okay, next. Sorry, I'm going to make this smaller. Okay, so next, you use Fs or Fy. Okay, I'm going to use Fy first. So I'm going to put like this. So sum of Fy equal to 0, which means that I'm going to focus only on the Y component. Okay, so now, okay, By is upward. I assume upward, so I'm going to put that. Okay, so right now I assume upward is positive, downward is negative. So By, I assume upward there, so I got positive By. Okay, and then 110, the Y component is downward, so minus 110 sine 33.7. Please take note, you don't have to multiply with the level arm. Only moment that you need to find, only moment that you need to multiply with the level arm, because force is about force, only force, it's not moment. Okay, and then minus 2295, this one, and then plus with the AY. AY already find the answer, which I get 2328. This is AY. And then the last one is going to be 660, which is downward. So minus 660 sine 71.6 degree, which is equivalent to what? 0. So I can find By, and I can actually know whether my By is correct or wrong by the directions. Okay, so I'm going to get 110 23.7 minus 295 plus 2328 minus 660 sine 71.6. So I'm going to get my answer is positive, right? So when I transfer it, I'm going to get my By is 654.3 Newton, which means that the directions of my By upward is correct because I get positive answer. Okay, so you don't have to give statement for that. Only for the negative part you need to give a statement. Okay, next one. I need to use the Fx equal to 0. Okay, so wait, I want to do some border over here because there will be a lot of calculations. Okay, so now I focus only on the Fs. Sum of Fs equals to 0. Okay, so when I focus on Fs equal to 0, which means I only focus on the right and on the left. Okay, so this one I assume positive to the right and left is negative. Okay, focus only X component. Okay, which means that you don't have to multiply with the level arm. Only focus on the force in X component. So now my Bs here I assume to the right, so that's why I'm going to put it as a positive Bs. Okay, 110, yes, I see that there's a S component over there because I resolved the component. So I'm going to get, okay, it's to the left, should be negative 110. It's not sine, it should be cos 33.7 degree. That's the reason why you need to make sure that the vector part, the first part, you need to make sure that you fully understand how to get cos and sine, because this one is definitely application. Okay, so AY, is there any S component? No, AY only have Y component, so you don't have to put there. And the 660 definitely have a S component, which is to the right, so you put as minus 660 cos 71.6 degree equals to what? 0. So you find the BS first, whether my directions is correct or wrong. So negative 1, 0. Cos 33.7 minus 6 is 0, cos 0.6. Okay, I got my answer for the FS. I got it. No. Oh, sorry. CC0 is not negative, right? No. CC0 should be positive. Sorry. It should be positive over there, okay? Because it's moving to the right. Okay, sorry. Okay, so I'm going to get negative 110 cos 33.7 plus CC0 cos 71.6. So I get 116.8, and my answer is negative 116.8. Okay, which means that, what does it mean? It means that my assumption here is wrong. It means that my BS should be to the left to balance out all the X component. Okay, so I need to give a statement here, so I put it as the directions of BS. Direction of BS should be towards, should be towards, it should be to the right, should be to the left. Okay, please make sure that you give your answer specifically. Don't give your answer opposite direction. Make sure that you put it upward, downward, left or right. Okay, so you don't have to fit, you don't have to make a correction to your FBD. Just leave it like that. Okay, just give a statement, then you get marks for that. Okay, so now, okay, but the question asks you to find the resultant reaction force. When the resultant reaction, it means that you need to find a magnitude and direction. So right now you only have BY and BS. The question asks you to find B, not BY and BS. So you need to use the concept from the first part, which for you to find the B, the magnitude, you need to put as the BX squared plus BY squared. Okay, so you put the answer over there. So BS is, okay, you can actually put the negative, or okay, or maybe you can actually put the correct directions. Okay, right now my BS is negative, but okay, negative, which means that the true direction is to the left. And from my knowledge here, my negative here, sorry, okay, my negative here is my left should be negative. So I can actually put the correct directions there, because it's still square, you still get the same answer, but it's better for you to put the correct direction, and your correct direction is positive or negative, depends on your upward, downward, left and right. So it should be left negative, I put this negative 116.8 square plus BY is upward, so 654.3 square. So I need to find the answer, which is 116.8 square plus 654.3 square. Square everything, supposedly I get 664.6 Newton. Okay, this is magnitude, and I need to find the direction, which is I need to use tangent theta. Okay, this is a tricky part. You need to put the correct direction. If you get negative, you make it correct, and then you find the correct direction, whether it should be negative or positive. Example, okay, you assume left, but you get your answer is negative, so the direction should be to the right, and your right is based on your you assume a right is positive, so that's why you are going to put your angle to the right is positive. Okay, so now, okay, tangent theta is about BY over BX. Okay, so here the tricky part. Okay, my BY, okay, for the BY I get positive. Okay, and okay, I look back at my assumption. My BY here is upward, and upward is positive. Okay, and then I get positive, so I put it here is a positive 654.3. Okay, for the BS, I get negative. Oh my god. I get negative, which means that my assumption is to the right. So when I get negative, it should be to the left. And left, I assume here is negative. Okay, so I need to put at the tangent the true direction with the correct sign. Okay, I repeat. My BS, I assume to the right. Okay, but I get my answer negative, which is negative means wrong. Okay, so my true direction is going to be to the left. I put here my sign left is negative, so that's the reason why here I need to put negative 116.8. Okay, so at the tangent part, you need to put a true direction with the correct sign. True direction with the correct sign. So like example, if I assume my answer, I assume upward, I assume downward, but my answer I get negative. So the true direction is going to be upward. And upward, I put at my sign, upward means what? Positive. And then I need to put the true direction with the correct sign at tangent theta. Okay, that's the tricky part, because this one going to affect your diagram. Okay, so make sure that you put a correct sign with the true directions. Okay, so 654.3 divided by 116.8. You don't have to put negative in your answer. Okay, 654.3 divided by 116.8. You are going to get your theta is 79.84. Okay, you are going to get 79.84 degree. Okay, it's not done yet. The last one going to be diagram. Okay, so when it comes to diagram, you are going to look at this one, which means that this one is already the true direction with the correct sign. So my BS is so my BY is upward, positive. Okay, okay, BY is upward, and my BY is upward, and BS is negative, which is to the left. So means that my diagram for the reaction force at support A going to be here. Okay, and the angle should be here, so I need to write 79.84 degree with the magnitude of 664.6 Newton. Okay, that's how you do it, and that's the reason you are going to get 14 marks. Okay, it depends on the complexity of the question. Okay, got it? Okay, if you didn't understand for the tangent theta, okay, you may ask me during online teaching, because that one is quite tricky. Okay, okay, so let's proceed to the next one. Okay, so this one, you have a different kind of questions, where this question you have inclined plane. Okay, so you have inclined plane, and as you can see that this question is quite easy, because the questions take weightless rigid bar, which means that you don't have to think about mass, you don't have to think about mass distributions. It means that your beam is weightless. Okay, so you don't have to think about the force of the beam. Okay, now I need to draw the FBD for this one. Okay, so when you have an inclined plane, like I mentioned you before, the directions of the beam on the inclined plane going to be perpendicular to the surface. Okay, perpendicular to the surface. Okay, so means that here when I draw perpendicular, okay, so this, okay, what is the angle? Okay, so this is the part 65 here, zigzag, you find 65 here. Okay, as you can see that, I make it large for you. This one is 90 degree. Okay, you need to find at this part. because this part is the same as this one. Okay, so 90 degree minus 65, then you are going to get 25. So this is 25 degree and this is also 25 degree. Okay, that's how we do it. Okay, that's how you get the angle for the A, for the support A. So the question asks you to find the resultant reaction at the support A and B. Okay, so when it comes to this, draw the FBD first as usual. Okay, show only forces and lever arm. Okay, for the B, I assume, okay, you need to assume, okay, you make the different assumptions. Okay, we are going to get the same answer with the same diagram with the same direction. Yep. Okay. Okay, so I assume that I think I want to assume my BY may be downward. I didn't know yet, and maybe my BX going to be to the left. I didn't know the answer yet. Okay. Okay, so okay, there's just like 3 forces only. Okay, and then you have, oh sorry, you have 62 degree right now over there. Okay, so this one is zigzag like this, so it means that it should be here 62 degree, and then you put your force here 216 lbf. So when it comes to lbf, pound force, this one is engineering system. Okay, okay, and then put your forces for the inclined plane. So it should be, I already showed you how to get the angle, so it should be like that. This one is 25 degree, and then we didn't know the value of A. So there's 2 forces that you need to resolve, which means that this one and this one. Okay, so this is going to be downward and right. This one going to be upward and right. Okay, so once you're done with that, make sure that you put the lever arm value. So this is 19 feet. And then this one going to be 26 minus 19. Then you get 7 feet here. Okay, once you're done with that, proceed to the calculation. So we are going to start with what? Moment, force, Fs or Fy? Yes, definitely you're going to start with the moment first. Okay, so start with the moment. Sum of moment equals to 0. Okay, is there any moment at the hinge? No. Okay, so you have to ignore moment at the hinge. You only focus on 216 pound force and E only. Okay, and you need to focus on the things that perpendicular. Okay, so 216 here, because my angle 62 degree touch Y axis, so here going to be 216 cos 62 degree, and this one going to be 216 sine 62 degree. Or you can actually use, if you don't want to use 62 degree, you can use 28 degree. So this one going to be 216 sine 28, and this one going to be 216 cos 28. Okay, so use angle that you can avoid careless mistake. Okay, okay, so I'm going to use 62 degree also. Okay, so it's going to be okay. Okay, so 216 pound force, clockwise or anti-clockwise? It should be, okay, my hinge is here. Okay, so it's going to be anti-clockwise. So I assume my anti-clockwise is negative. Okay, positive, negative. Okay, it's better for you to put a reminder here. The directions of the clockwise or anti-clockwise is like to remind you and to make sure that you didn't do careless mistake when it comes to the sign. Okay, one sign wrong, what happens is all the calculation is going to be wrong. Okay, that's the tricky part for this kind of questions, the mechanism part. Okay, okay, so it's going to be anti-clockwise, so I'm going to put it here as a negative 216. I'm going to use 62, right? So I put this cos 62 degree multiply with the lever arm. So the lever arm going to be what? 19 from the hinge up until force. From the hinge up until force. Okay, so 19. And then for the A, you need to divide into, you need to resolve the component into y component and x component, because you need to find the force that perpendicular. So the one that perpendicular here is AY, not AS, okay, AY. Okay, so it's going to be clockwise or anti-clockwise? It's going to be clockwise. Okay, so plus AY sine, just put A. This one going to be AY. Okay, A sine 25 multiplied with the level arm. So the level arm is 26, right? Okay, from the hinge, I'm anti-force, so it's going to be this one. So 26 equivalent to what? Equivalent to 0. So you're going to get your value for A. Okay, so your A here going to be 816.8. 816. Okay, 216 cos 62 times 19 divided by 26 sine 25. So you're going to get 175.3. My A going to get positive, right? So 175.3 pound force. Make sure that you write the units. Don't forget the units. Okay. Okay, so you already find the one unknown. Now you need to find the B, the BY and the BS. Now you need to find the now you need to find the BY and the BS. Okay, the hinge value. So you are going to put that as a Fy equals to 0. Only focus on the force, which I assume upward is positive, downward is negative. Okay, so my BY, I assume here I get negative because it's downward, negative BY. Doesn't have to multiply with the level arm. Minus with the 216 for the x component, okay, which is negative because it's downward, negative 216 cos 62. Okay, and the last one going to be the inclined plane here. So here, the y component. Okay, so it's going to be, you already get the A, right? So it's going to be plus 175.3 sine 25 degree equals to 0. Equals to 0. Okay, so you are going to get your BY, negative or positive, 62. So negative plus 175 is sine 25. So you are going to get 37.32, and my answer is negative. Yeah, I get negative value for this one. What does it mean? It means that my assumption is wrong. So supposedly the correct directions to balance out everything, to balance out for the y component. So I need to put here direction of BY should be upward. Okay, so for those who assume upward, your answer for the BY definitely you are going to get positive. If you get negative, double check the sign. Okay, maybe there's something wrong over there. Okay, that's why I said that your assume at the end all the answer going to be the same answer. Okay, if you assume like upward or downward, at the end you are going to get only one direction, which is the correct one. Okay, okay, the next one is sum of Fs equals to 0. Okay, so we focus only on the Fs, the x component, which I assume right is positive and left is negative. Okay, so now my Bx I assume is to the left. Okay, left. Okay, so negative Bx, and then for the 216 is basically to the right, so you put positive over there. 216 sine, I'm using 62 degree. If you use 28, then you need to use cos. Okay, don't have to multiply with the level arm, and then plus Also for the A, to the right. Okay, so you are going to get here A, I already get the answer 175.3 cos 25 degree, and then equivalent to what? Equivalent to 0. Okay, so you can find your answer for the BS, whether my direction is correct or wrong. I need to look at my answer first. 16 sin 62 plus 175.3 cos 25, so I get 349.4. okay, my answer is positive. I get 349.6 lbf. What does it mean by positive? Which means that my answer is correct. The directions for the BS to balance out all the S component is to the left, which is correct. Positive means correct, negative means wrong. Okay, so this is the next part. Because the question asks you to find the resultant reaction, so means that you need to find the magnitude and direction, which means that you need to find the tangent theta and also the BS square plus BY square, square root everything. Okay, so find the magnitude first. Okay, so the B here is the formula going to be BX square plus BY square. Okay, so you're going to get here is, okay, so the BX square is 349.6 square plus with the BY over there is, okay, you can actually put the true directions with the correct sign, or you can just put just like that, because square you are still get the answer going to be positive. So here I'm going to put the true sign after this. Okay, so I just put it negative 27.32, because definitely you are going to get positive square, right? So the answer going to be 349.6 square plus 27.32 square, square everything. You are going to get 350.7, and the unit is lbf. Okay, you are not done yet. You are not done yet. You need to find the tangent theta. Okay, for the tangent theta, I'm going to use the true directions with the correct sign. So the by over the bx here. So you are going to get your by. Okay, I get my answer. By is negative. Here I get negative. I assume my direction is downward. So supposedly my direction, the correct direction, it should be upward, and because of upward, I put my sign here is positive. Okay, I repeat, I assume my direction downward, and then I get my answer is negative, which is wrong. So the correct direction should be upward, and here I put my sign as a positive when it comes to the upward. So I'm going to put the true directions with the correct sign. So it's going to be 27.32 positive. Okay, and then my BS over there, okay, my BS over here, I get positive, which is my direction. My assumption is correct. My god, I'm wrongly correct, which means that here my BS is towards the left. I assume negative. Okay, I get positive, which is correct. I assume my direction is BS to the left, and then I get positive answer, which is correct. But left here I put as a negative. Left here I put as a negative, so I'm going to put negative over there. So it's going to be negative 349.6. okay, you don't have to put negative and positive in your answer, just put the number only. Okay, 27.32 divided by 349.6. so tangent answer, you are going to get 4.47 degree. Okay, so when it comes to the diagram, you are going to refer to this. Okay, the true directions with the correct sign. Okay, so here my by is positive, which is upward. Okay, and then I get bs is negative here. So here, so means that my direction is going to be here. So this is going to be 4.47 degree, and the magnitude going to be 350.7 lbf. Done. Okay, so basically the steps is going to be the same thing, but you need to be extra careful with the sign. Okay, be extra careful with the sign, and then supposedly everyone you should get this direction. Okay, if you get different directions, definitely your answer is wrong or direction is wrong, and you may refer to me if you didn't understand. Okay, during online teaching. Okay, so let's move on to the next part. Right. Okay. Yeah. Okay, so we have different type of questions. Okay, so I give you 3 different type of questions because these questions might be asked in your exam, in your test. So that's the reason why I need to show you how to solve the questions for different type of how to solve it with the different type of questions. And I think maybe you are going to get some understandings over there. So if you feel that quite confused, please ask me during online teaching. Okay, this one but this one is quite easy if you practice a lot. Okay, so you need to practice a lot, do all the questions in the tutorial, and do all the questions that I give it to you, and definitely you are going to get full mark if you do that. Okay, so let's proceed with the next this one. Okay, this one is quite different from the previous 2 questions that I show you before. Okay, so this question, you have this thing we call as 1200 feet lbf. Okay, what does it mean by this one? Okay, this one is basically moment. Okay, so this question is different, where now you need to imagine that this beam is actually moving in rotational motion with 1000 feet pound force. So this is basically moment because this is force with a distance. Okay, so now you need to find the value of B. They need to balance the external moment. You need to find the value of B that need to balance value of B A that need to balance out the external moment of 1200 feet pound force. Okay, but please take note when you have this extra thing. Okay, you need, I already give you the directions. These directions is basically clockwise motions. So 1200 pound force only can be written in moment only, which means that in your calculation this 1200 only exists at the sum of moment equals to 0. For sum of forces Fs equal to 0 and sum of forces Fy equal to 0, you don't have to put it, because as you can see that we didn't know we didn't know the level arm. So if we know the level arm, definitely we going to know the value of the forces, and this is basically moving as a whole body. Okay, the whole body of the beam is moving with 1200. So that's the reason why we didn't have to put in Fs on Fy. We need to only put in the sum of moment equals to 0. Okay, so let's start with the first part, which is definitely you need to draw the FBD. Okay, and then you can see that here you have a mass distribution, which means that you need to find the force first. Okay, so and mass distribution, this one is for pound mass, so definitely you need to use engineering system. Okay, that's how you detect. Okay, so I'm going to show you the calculation first. I need to convert the 56 pound mass feet into weight or gravitational force. Okay, so I'm going to show it here. Okay, I draw. Okay, so the 56.0, so I put it 50.0 lbm per feet. Okay, you need to multiply with what? The whole length of the beam. Okay, so the whole length of the beam is 11 plus 19 plus 9, then you get 39 feet. Okay, you get 39 feet. So multiply by 39 feet. So you are going to get 2184 pound mass. It's not done yet. You need to find the gravitational force or weight. Okay, so F equals to MGL over GC. So 2184 lbm multiplied by 32.1740 feet second square divided by 32.1740. Okay, why I use 32.1740? Because this is engineering system. Okay, that's the reason why you need to detect. And please recall back for the GL and the GC. Okay, LBM over LBF feet per second square. So the value going to be, this one can be cancelled out, so you are going to get the same answer. Okay, but you need to show the working step. This is going to be 2 marks. Okay, okay, where is the directions for the 2184? Is going to be at the center. Okay, always take note, always be at the center of mass. Okay, so let's start with the FBD, the free body diagram. Okay, so draw the FBD. Okay, include all the forces. Okay, so for the B here, hinge, so I need to assume. Okay, so I assume it's going to be upward and to the left. Okay, I assume. Okay, and for 87 pound force, okay, 87 pound force, okay, I need to find the angle first. Okay, so the angle is going to be 4 divided by 6 tangent theta 33.7. So I find it here is going to be 33.7 degree. Okay, and then for the A is going to be definitely upward, so I did it as a AY. And then for this one, 660, it should be 46, so this is ZZ 46. So here going to be 660 pound force 46 degree. Okay, and there's another one which is the mass of the beam, which is here, 2184 pound force. Okay, then you need you put all the level arm. This one going to be 11 feet. This one going to be 19 feet, and this one going to be 9 feet. Okay, okay, so next part is I'm going to resolve all the forces. So this one is much easy for me to see the direction. Okay, like that. Okay, okay, so you are going to have 1 2 3 4 5. So make sure that you have 5 forces. Okay, then you proceed with the calculations. So definitely you are going to start with the sum of moment equals to 0. Okay, sum of moment equal to 0, so means that at the hinge there will be no moment. Okay, so focus only the force that perpendicular. So definitely this one, this one, this one, and this one has a moment because force perpendicular to the level arm. Okay, so I start with the 87 first. Okay, 87 clockwise or anti-clockwise is going to be anti-clockwise. Okay, so I put it here. This is positive, anti-clockwise is negative. Okay, so always put the reminder because it's to make sure that you put a correct sign. Okay, so negative 87, sign or cos? Yes, it should be sign because 33.7 touch as this sign 33.7 degree. Okay, and then 2184 clockwise or anti-clockwise? Yes, it's going to be anti-clockwise. So 2184 level arm going to sorry, I didn't put the level arm here. Okay, yeah, okay, so because moment you need to multiply with the level arm. Okay, so sin 37 multiply with the level arm, so you are going, your level arm is 11, right? 11. Okay, so minus, okay, minus because anti-clockwise. 2184 is you get anti-clockwise. Okay, please don't assume downward and upward. if you put upward and downward, you are going to have trouble when it comes to the sign. So please, moment only focus on clockwise or anti-clockwise. That is the common mistake students always make in exam, in test or quiz. Okay. So 2184 multiplied with the level arm, which is at the center. So at the center going to be what? 19 plus 11 plus 9 divided by 2. So you are going to get 19.5, right? Okay, 19.5. Okay, for the AY, clockwise or anti-clockwise? Yes, very good, clockwise. So it's going to be positive, AY. What is the level arm? Level arm going to be 11 and 19. So it's going to be 30. Okay. And the last one, since it's 0, anti-clockwise or clockwise? Yes, definitely is going to be anti-clockwise. That's why you put negative here. Negative 6 is 0. Sine or cos? Sine. 46 point degree. Degree. And the level arm going to be 39. Yes. Okay. Okay. And then there's another one, which is I said before, we have 1,200 here. Okay, 1,200, which means that you need to put into your moment. Okay, it's moving clockwise. That's why you need to put plus here. 1,200, because that one you don't have to multiply with the level arm, because the answer, because the 1,200 already in moment value, which is unit is force and the distance, which is feet pound force. Okay, and then you equivalent with what? Equivalent with the 0. Okay, so you are going to get 7 sine 33.7 times 11 minus 2184 times 19.5. 6 is 0. Sine 46 times 39 plus 120 divided by 13. So you are going to get your AY or A, you can actually just put it. AY is 2014.5 pound force. Okay. Okay. If you get different answer, it means that you forget to put 1,200 in your calculations, and make sure that you double check. Always double check your sign. Okay, that your sign here is very important. Okay, so let's proceed to the next one, which is FS and FY. Okay, this one you don't have to put the 1,200. Okay, so I start with the sum of FY first. Sum of Fy equal to 0. Okay, so I only focus on the force, not level arm. So I don't have to multiply with the level arm. So my assumption By over there is upward. I assume upward is positive, downward is negative. So By, and then 87 downward minus with the 87 sine 33.7 degree. Minus with the 2184 because it's downward. And then plus with the AY, I already get the answer for the AY, and then it's upward, so it's positive. And then minus with the 60 pound force, sine 46 degree. Okay, you don't have to put the 1,200 in your calculation. 1,200 only in moment. Okay, not FS and FY. So you just put it equivalent to 0. Okay, so I need to so now I'm going to see that whether my By, the direction is correct or wrong. Correct or wrong, right or wrong. 87 sine 33.7 minus 2184 plus 2014.5 minus 60 sine 46. Okay, so supposedly for the By, I get my answer is positive, right? Okay, which means that my answer is correct. My assumption is correct. So I get 692.5 pound force. Okay, so when I get positive, it means my assumption here is correct. Okay, upward. Okay, next one. Okay, I need to have some space here, so I need to shrink the questions here a little bit. Okay, that's the reason why I don't have much space. Okay, so next one, I'm going to use the FS, sum of FS. sum of fs equal to 0, which means that I only focus on the s component. Okay, so my assumption here, bs is to the left, negative bs. And then plus, minus also with this 87 cos 33.7 because it's towards the left. AY doesn't have any S component. 21A4 also doesn't have any S component. And the next one going to be cos with 33.7 plus with the 660 to the right, cos 46. That's why I'm using a positive because it's to the right. So equivalent to what? Equivalent to 0. Okay, so you are going to get your answer is whether my direction is correct, right or wrong, I don't know yet. This is 0 cos 46 minus 87 cos 33.7, and I get my answer is positive, which means that my directions is towards the left. Yeah, it should be towards the left. Okay, so if my BS is correct, the directions I get is correct, which is 386.08 pound force. Okay, I get positive answer here, which means that my directions of the BS is basically correct. It should be towards the left. Okay, so for those who assume to the right, you are going to get negative answer. Okay, that's the okay, so means that you need to put the statements over there. The true directions for the BS should be towards the left. Okay, so for those who assume towards the left, definitely you are going to get positive answer. Okay, so next is find the magnitude and directions. Okay, so find the magnitude and directions. So means that here you are going to put the B. Okay, you don't have to like write the formula like this, like I'm doing now. I just want to show to you. You just can skip and you just put the number over there. Okay, but you need to show the working step. Okay, so my BS is 386 square plus my BY is 692.5 square root everything. Supposedly I get my answer is 386.08 square plus 692.5 square. I get 792.9 pound force. Okay, and then I need to find the tangent theta. This one I need to put the correct directions and the true sign. Okay, so the BY over BS. Okay, so for the BY here, okay, BY I assume upward and then I get positives, and then my positive here is my upward is positive, so therefore I can put the positive over there. So going to be positive 692.5 over, okay, for the BS I get my answer correct. I assume to the left, which mean correct, which mean there I assume my BS is left negative, right positive. So means that I need to put, okay, because I get correct directions which is towards the left, I put negative, towards the left is negative, so it should be negative 386.08. okay, don't put negative and positive in your calculator, just put the number 6.08. So your angle going to be 60.86 degree. Okay, so the last one going to be the direction. Okay, so the directions, like I mentioned before, you need to look at the correct directions with the true sign. Okay, with the true sign. So the Y is upward, positive. Okay, positive, and I get X component is negative. So my answer going to be in this direction. Okay, so put the sign, which is 60.86 degree, and your force magnitude is 792.9 pound force. Okay, then you are done. This is the working step. So you can actually see that even I show you 3 different questions, the working step is almost the same, but at the beginning is going to be a little bit different. Okay, so please do the questions that I provided for you. Okay. Okay. Okay, so this one is another question, but this one is pretty easy. I give you already the working steps over there, so you need to show, but I didn't give you a full working step. You need to show me the full working step, so you can actually refer to this one. And also you can actually refer to this one. Okay, this is basically the same thing that I mentioned before, which means that for this one you need to put it only at the sum of moment equal to 0, but you don't have to put at the fs and you don't have to put at the fy. Okay, because this is what? This is moment, which means that the beam is actually rotating now, and then you need to find the value of a to balance the rotational, to balance the beam that actually moving in rotational motion. Okay. Okay, and this one also, okay, this one we have a tensional force. Okay, so you can actually refer to this. This is the FBD, but this one is not correct. You need to make sure that your force always be upward. Okay, and the hinge here is basically assumption only. Okay, here is only assume, so you can actually put your assumption, different assumption, but you're still going to get the same answer. Okay. Okay, so I want you, okay, so this is the same thing also. Okay, but this one you have the reaction force at the B, which is pointed downward. Okay, it's always be perpendicular to the surface, and then you have the hinge over there. Okay, and then you have the beam that actually moving with a 2 kilonewton meter. Okay, so this is like the combination questions, that this may be questions that you're going to ask in your exam. Okay. Okay, so once you're done, once you finish, please do this question, the practice one. Okay, I'm going to give it to you, the answer, during online teaching. I'm going to show you the working steps. Okay, feel free to ask me any question. Okay, and also for the practice 2, it's a little bit different, but the questions, the working step is almost the same like I mentioned before, but this one you have a tensional force. Okay, I want to know how you draw the FBD, and please ask me during online teaching. This is quite complex questions for your level. Okay, so if you need anything to clarify, feel free to ask. Okay, so I think that's all for now. I'm going to see you during online teaching, and we are going to see during online teaching, and then for the next chapter. Okay, so that's all. Thank you very much. Assalamualaikum and goodbye.